So if one day it was reduce, reuse, recycle, today it's different. It's become more evolved. And we've as an industry and all the community that surrounds that industry, we've come up with a lot of different ways of recovering materials and recovering packaging. The middle sort of three tiers here aren't really set in stone in their ordering. I don't think there's any consensus in the sustainability community if anaerobic digestion is more preferable than composting, or if energy recovery is maybe more preferable than composting. But the message I want to share with you is that there is a philosophical backing to the waste hierarchy. Put simply, not all forms of recovery are created equal. So often we say and we hear things about, well, our number one objective here is getting this material out of the landfill. And there are different forms of recovery, but they're all recovery. And that's true, but we want to argue that getting things out of the landfill is step one. Getting them to the most beneficial form of recovery is the ultimate goal. So the thinking behind the waste hierarchy, the reason that we have these different stratifications of recovery is this idea that as we build packaging, we are investing both financial and environmental resources into that material. We're taking something from the natural environment, and as we build it into a package, that has its associated environmental, social, and economic impacts. The theoretical best form of recovery is the one that retains the maximum embodiment of those investments so that the impacts associated with reinvesting into that material can be avoided. So, for instance, if we think about bioplastics from crops, composting creates a material that can help grow new crops, and that's a good thing. One step up, though, recycling can bypass that, can bypass the need to grow new crops. Reuse can bypass the need to make new pellet. And I don't get to talk about all of these different forms of recovery, but I want to start with reuse. And if I could ask for a show of hands, how many of you have ever heard a discussion of bioplastics and reuse? Right. Typically, we talk about composting, recycling, maybe. Everybody heard of the new plastics economy? Right? A lot of the brand owners that are here are enthusiastic participants, I'll say, of the new plastics economy. And the new plastics economy is ambitious, and I'll wager that it is fairly idealistic in its nature. But part of the new plastics economy says that 20% of our plastics should be reused. Another big tenet of the new plastics economy is that any of the virgin sourcing of new plastic materials comes from bio-based feedstock. So in essence, what the new plastics economy is saying is that we need bioplastics and they need to be reused, right? And 20% reuse is ambitious. I have no clue what the number is today. It's a far cry from 20%. So this is what we call the life cycle of a package. This is our famous, the SPC donut, we call it. And the idea is that when we take feedstocks and we build a package and the package gets used and it gets to its end of life, we want to see it do something like this, where it travels in a circular fashion, right? That's the whole underpinning of this idea of a circular economy. Reuse does something like this, right? So it stretches that life cycle out. The feedstock goes in, and then the material has its life cycle of becoming a package and being transported and used, and then it can do that again, and then again, before you finally reach that end of life. Now, whenever we talk about reuse, it's important to think about different applications of reusable packaging. Reuse makes a lot more sense for some packaging formats than others. KFC got dinged pretty hard when they decided to put all of its sides in these durable, reusable plastic containers, because it's not as though people could bring them back to KFC and they would be reused there. And there's the consideration of over-engineering plastics for purposes of reuse when they're not actually likely to be reused. So where we believe the big opportunity is in things like transport packaging, reusable pallets, reusable crates, items that by their very nature need to be durable. A lot of opportunities for reuse in that. We've never seen a lot of conversation around using bioplastics for these materials. But again, the energy we see behind the new plastics economy and all the conversations that are coming out of that, it feels like this ought to be on all of our radars. Bioplastics, need to be reused. Moving on, recycling. 10 years ago, we couldn't talk about bioplastics and recycling because it wasn't possible. Today it is. In a nutshell, we think of recycling as being this sequence of processes, and each of these are necessary to have success in before something can actually be recycled. So there has to be a collection mechanism in place. We have to find some way to accumulate the material and transport it to the next step, which is more often than not a sortation facility, a material recovery facility, MRF, a MRF. It doesn't have to go to a MRF if there's a dedicated collection stream, but more often than not, the way that we recycle things is by collecting them in a commingled mix and sending them to a sortation facility. So for an item to be successfully recycled, it does have to successfully sort. And material recovery facilities, for the most part, are automated, and the automated sorting equipment relies on identification of certain characteristics of a package. It could be, is it two-dimensional or is it three-dimensional? Is it magnetic? Is it not? Is it electrically conductive? If we use something fancy like an infrared sorter, what is the wavelength? And how does that interact with the molecular structure of the polymer? So these type of questions need to be asked when you think about, can this successfully be recycled? And then finally, reprocessing. So something, unfortunately, we see things that get collected very well, they sort very well, but then some technical nuance of that design prevents it from being successfully processed and actually completing the recycling process to become a new package or product, offsetting virgin material. Because really that's what the ultimate goal of recycling is, offsetting the use of virgin material. So there's this big divide between what I call theoretical recyclability and practical recyclability. And most everything is theoretically recyclable. Almost anything can be collected and transported. There's some unique physical characteristic of that material that can be exploited to identify it and remove it from the commingled mix at a sorting facility. And there is a reprocessing technology that can make something out of almost any material. In terms of practical recyclability, we want to ask, what's the real likelihood of that happening? So at the SPC, we oversee the How to Recycle program, and we issue labels with different tiers of recyclability to packaging. And these are the type of questions that we have to ask when we look at a package. So for bioplastics, there are a few different options. And what probably comes to mind first is, okay, for a bioplastic to be recycled, it either has to be the bio-based equivalent of a conventional plastic, like bio-based PET. There's already a PET recycling stream, so we're good there. A new recycling stream has to be created, or interesting things like this. So this was in the news last week, and I pulled it and wanted to share it with you. PEF, a similar material to PET, but different enough. There was a study that said PEF can be included in the PET recycling stream. So I want to plant this idea in all of our minds that there are creative opportunities to take a novel bioplastic and find an existing recycling stream that's similar enough to where it fits. Now the fine print that's at probably the very bottom of this article says that PEF is fine in the PET recycling system as long as it's 2% or less of the stream. And PEF isn't going to overtake more than 2% of PET anytime soon. So that's okay for now. So it's the idea that fitting into an existing recycling stream can be a bridge strategy until an independent, dedicated recycling stream exists for the material. Okay, on to composting. The unfortunate first thing we have to talk about with composting is the availability of composting facilities that can process bioplastics. And the numbers are kind of scary, but I don't want to be doom and gloom because there's plenty of promising activity. But start with the doom and gloom. There are over 3,000 industrial composting facilities in the US, which is a lot, right? That's good. But the vast majority of them are only taking yard waste. 39,000 municipalities, 198 have municipal collection of organics. And of those programs, not all of them collect packaging. So there are very few communities that have a residential composting program, not just residential, also available to commercial entities, that will take food waste, and then those that take food waste don't all take packaging. The good news is that of these few communities that are collecting organics and packaging, there are some really big ones. New York, San Francisco, Seattle, Washington, D.C., I believe, is coming online. So if we believe in a system where change starts in the biggest urban areas and proves a model for success and that spreads outward, the foundation is there. But by and large, when we look at the United States, there's not widespread infrastructure for composting. Composters have a complicated relationship with bioplastics, as I'm sure many of you know. In short, they don't love it. But what they do love is food waste. And we believe there's great potential for compostable bioplastics to be a part of a system that delivers more food waste to composters. If we think about the slice of the pie of our overall waste composition that is food waste, it's immense. It's something like 30%. 30% of everything we throw out is food. And right now, almost all of that food waste goes to the landfill, where it's a huge source of man-made greenhouse gas emissions. So diverting that food waste from the landfill is a big, important part of getting to anything close to resembling a zero-waste economy. And compostable packaging is the only way to get a large portion of that food waste out of the landfill into an industrial composter that can beneficially reuse it. So we see a lot of promise for compostable compostable bioplastics. I'm supposed to be careful with our terminology today. Interestingly, the recycling community also has a complicated relationship with compostable bioplastics. But I want to summarize the two main issues that composters have with compostable plastics with these two slides. So problem A is what we're looking at here, and those are not compostable forks and spoons. Those are conventional, non-compostable pieces of plastic cutlery that made their way into some type of composting program that was intended to take compostable packaging. Likely whoever the food service operator was had mostly compostable packaging, but also some conventional cutlery, and they get into the composting stream. Composters don't like this. Problem B is this: these are compostable pieces of cutlery, and they were certified compostable, but as I think I get to explain in our last part of today's training, not all compostable plastics are equal in the minds of composters. So there's all sorts of nuanced considerations for the time it takes to satisfactorily compost, the conditions in which it will do that. So composters receive bioplastics that are certified compostable but don't fit the specific parameters of their operation. Lookalikes. So to pick on our friends at Solo Cup, these are 2 cups from their Bear line of products. The one on the right, fully compostable. Show of hands, who thinks the one on the left is fully compostable? Right, of course you don't, because I set you up for this, right? The one on the left is 100% PCR. So it's got a sustainability story to it, and therefore this line is the greener line of products. But you already know where I'm going with this. If you're a consumer and you're at an event and there is composting collection for packaging and you have the cup on the left, it's probably going to make it into the stream and go to the composter. The lookalike game is really fun. So there's a ton of these, right? Which one is molded fiber? Hands for the one on your right. Yeah? Hands for the one on your left. Yeah, I don't know which one is which. Yeah, I just remember that one's molded fiber and one's polypropylene, but it's supposed to look kind of like molded fiber, right? It's supposed to have that connotation of being a natural material. This is a problem, right? Last one, green film. The one in the middle, the one in the middle is our certified compostable bag. No problems in almost any industrial composter. The one on your left is an oxo-biodegradable bag. So this is a conventional polymer, and it has those additives that Paul discussed that purport to turn a conventional polymer into a biodegradable polymer. These bags, even if they are biodegradable, are not compostable, because we all know that biodegradability and compostability are 2 different things. They've even got an imagery of a leaf on them. So again, these are going to get into the composting system. On our far right, of course, are the conventional produce bag that are often tinted green because it makes your produce look a little bit greener. In Seattle, there's a big push to outlaw green produce bags made from conventional plastics because they look a lot like the compostable counterparts. So again, I belabor this point not to be too doom and gloom, but to say there's a lot of work that needs to be done in order for the attitudes of composters to improve towards packaging. There's a reason that it's been a complicated relationship. But again, we see a lot of very encouraging pieces of activity underway. And the whole idea of sending packaging to industrial composters is a new idea in relative to other activities. So we see it climbing steadily towards its maturity. Okay, lastly, landfilling. So what happens when a bioplastic goes to a landfill? Really, really, really depends on the type of bioplastic, right? So if it's a non-biodegradable bioplastic, it will sit in the landfill alongside any other conventional plastic and be inert. It will do nothing. Interestingly, this isn't going to give anybody the warm and fuzzies, but because a bio-based plastic has sequestered atmospheric carbon in it, if it goes into a landfill and does nothing, that's storage of atmospheric carbon. That's a greenhouse gas sink. From a carbon perspective, it's actually a good thing if a bio-based plastic doesn't biodegrade in a landfill. I said it wasn't going to give anybody the warm and fuzzies, right? The ones that do biodegrade in a landfill, this is what always needs to be said. Things that biodegrade in landfills do not suddenly turn into wildflowers. There's no completing of the natural cycle when a bio-based material biodegrades in a landfill. Landfills are super regulated and very, very engineered to isolate waste from interacting with the natural environment in any way. So if something does biodegrade in a landfill, let's say it creates this beautiful, rich, earthy brown biomass, it's still going to stay in that landfill isolated from the rest of the world around it. So we don't want anybody to have any connotations of it being preferable when things biodegrade in the landfill. When things do biodegrade in the landfill, they do so anaerobically, as in without oxygen, and the anaerobic process of biodegradation creates carbon dioxide and it creates methane. The carbon dioxide we say is a wash if something is bio-based because that carbon used to be in the atmosphere, we took it out, we put it in a plant, we took the plant, made it into plastic. The plastic then releases the carbon dioxide back in the atmosphere, so it's net neutral. The methane, however, the rule of thumb is that methane is 25 times worse than carbon dioxide from its ability to trap greenhouse gases in our atmosphere. So the methane portion is considered a human-induced greenhouse gas emission. And we have to remember that landfills are, I believe, the third largest source of methane emissions that are cataloged by the Environmental Protection Agency. So in short, biodegradation in landfills is not preferable from at least a carbon perspective. Now, of the subset of bioplastics that are biodegradable, not all of them are anaerobically biodegradable. So I don't think we have enough time today to go into the nuanced difference between aerobic biodegradation and anaerobic biodegradation, but it's a question that should be asked of biodegradable plastics. What happens when they go into a landfill? Are they likely to stay inert, or are they going to biodegrade and be a source of greenhouse gas emissions? Okay, lastly for me, marine plastic pollution, an issue that is not going to go away anytime soon, and it deserves our attention. What we learned from our peers at the Ocean Conservancy is that marine plastic pollution is a waste management issue. It's not necessarily a consumer behavior issue. Their findings suggest that the reason that we have marine plastic pollution is because these materials don't have a happy home in a recovery infrastructure. And most of the plastics entering our marine environment are from some East Asian countries where there is a total lack of recovery infrastructure. So the message in short is if we want to get rid of marine plastic pollution, we need to value plastics. We need to find higher and better uses for them at their end of life. We need ways to recycle them. We need reuse. We need composting. I also am not touching on terrestrial litter because the feeling today is that basically anything that's littered on land is going to make its way into a waterway. So there's a decreasing level of distinction between terrestrial litter and marine litter. They are basically one and the same. I think the last point that we don't get to go into today is I'll start with the lack of an appropriate standard to determine if a material is marine biodegradable. Because on one hand, that would be a pretty good thing, right? If we knew that a bioplastic was going to biodegrade in a marine environment, that could be part of the solution to marine plastic pollution. On the other hand, we say, is that really what we want? Do we want plastics that are certified marine friendly, litter friendly, basically? And I think the answer is no. It's open for debate. But it's something that we have to question. And from our perspective at the SPC, the best intelligence we have available says that the way to stop marine plastic pollution is to create a robust recovery infrastructure for plastics. And that needs to include composting, needs to include recycling, and needs to include reuse. I will stop there, and no clue if we have time for questions, but someone will tell me. No? Questions?
I've got one question. If the plastic is going to be a problem in the marine environment for a long time, and we know that it can't be controlled for years and years to come, what's the angle of the SPC that having a marine degradable plastic is a negative?
I don't think it's necessarily a negative. It's a complicated issue. I think the worst thing that could possibly happen is if we had packaging that was marketed, that bore a marketing claim of being marine biodegradable, this idea of marketing something as being litter friendly. A lot of what we've seen with the use of those biodegradability additives is that they're used on things like balloons and dog poo bags, and they're marketed in such a way that tells people it's okay to just put this plastic out in the environment. And even if it is okay, even if it truly is okay for that one item, even if it really is marine biodegradable, I think the official stance of the SPC, Nina's not telling me not to, is that we don't want anything that engenders a public consumer behavior of not putting plastics into their best, most appropriate recovery receptacle. But it's complicated. I think with the six-pack rings, the poster child for marine plastic pollution 10 years ago, with every one of those having a photodegradable additive, it's good, it helps the problem, but it works because nobody knows about it, right? Nobody knows that the six-pack rings have photodegradable additives and are likely to break up before they can strangle a sea turtle. So it's this complicated thing of, yes, we want marine biodegradable materials, but we don't want anyone to know that they're marine biodegradable, if that makes sense. Yeah. Raina.
Same, and I think there's a lot of focus on materials in the end of life and where they're going to go, and specifically around plastic. I think you touched on the next wave and the discussion about the material management issue. I think a big part of the problem is we're creating a ton of packaging and materials and products that are made out of things that have no value on the secondary market. So the focus, just at the end, how do we fix the collection and how do we create value out of the stuff that has no value at this point? That's one way of looking at it, and another way, or an additional way of looking at it, is how can we move upstream? And I know that Ellen MacArthur Foundation is also talking about this in their next, that is after the plastic second phase of their plastic economy. So it's just really important to think about that as well, designing for value on the secondary market.
Yeah, I think the best way of thinking about it is there's the activities of us who produce packaging, and then not represented here today is the activities of the recovery community, the recyclers, the composters, and there's this sort of tension of packaging producers saying, well, the recovery folks have to change to meet the packaging that we're putting out, and the recovery folks saying that the packaging that's produced needs to be optimal for the existing system. And both are right and both are wrong, and we need to see more meeting in the middle. Sure.
It's more than just the system, it's like the end markets for the products themselves. Because if I'm a collector and I have to sort through this material, I need to sell it to someone. And so the conversation is important for people that are putting materials out to understand what is the potential that material can be on that secondary market, or what can it turn into.
Right, right.
Just like a small distinction there.
Yeah, no, I'm with you. It's an important point. And I think the good news is that there's a lot of reach in industry and a lot of power and a lot of ways to create markets for some materials that don't have value today. I know it's not as easy as saying that, but theoretically, there is a solution. Sri.
So in the hierarchy that you showed, recyclability is better than compostability, right?
Theoretically.
So are there some parts of the world where compostability is a better solution for the waste management?
Yes, and that's the thing about the waste hierarchy, is that it is theoretical and idealistic. From a practical standpoint, we have to find the best recovery method that is viable and has the biggest effect of reducing environmental impacts. So, right, if something has to be transported halfway across the world and a long, elaborate process has to be undertaken to recycle it, it might not be more environmentally preferable than going 1 or 2 rungs down on the waste hierarchy for something that is viable, maybe at the location or for that specific material. But I think it's a constant game of you want to shoot for the highest possible and try to engender a system that makes that a reality. Okay, I'm sure we're out of time, and I hand it back to Paul. So thank you for your attention.